Welcome, everybody. Welcome, Karabo, Ozayo, Swelihle. We're going to be looking at Euclidean geometry today. I think while we wait for others, if you can just take out any textbooks or anything that you do have with your theorems in it, that will be really great. Or any notes that you have. I'm going to show you some of the theorems, but it will be great if you have yours next to you, because we're going to make some notes on those theorems as well. Welcome, Asipe. Also, welcome to those who are watching us live from the live stream. I hope that you all are doing well and that your school week has been going well. Welcome, Karen. Welcome live. Okay. So I'm going to share another worksheet. On Euclidean geometry. Wait. Let's just share it correctly. There we go. Coco, is that projected fine? You can see the worksheet on Euclidean geometry, huh?
Yes, we can. Thank you, Teacher Depesh.
Okay, thank you. Okay, great. Okay, so we've got another worksheet here on Euclidean geometry, which shows us all the rules. I thought it would be really nice to just quickly, in a speed, run through all the theorems, which I'm hoping that you know very well, but we're just going to give it another minute or two just for others to join. That's very small. I think let's stick on this one. Maybe I can do that, right? Yeah. Okay, while we wait, I'm just going to browse through the different theorems. Theorem 1, which is line from center perpendicular to chord. And then we've got the next theorem, which is angle at center is 2 times angle at circumference. We've got theorem 3, which is angle in semicircle equals 90 degrees. And we've got theorem 4, angles in same segments are equal. We've got theorem 5, which is opposite angles of cyclic quadrilateral are 180 degrees. Supplementary. We've got theorem 6, which is exterior angle of cyclic quad equals opposite interior angle. We've got theorem 7, which is tangent is perpendicular to radius. We've got theorem 8, which is your tangents from the same point are equal. Theorem 9, the 10 chord theorem. And that's that for the circles, right? How many of you know all these theorems by heart and have used them? You can just show me a thumbs up. How many of you know them all and have used them? Thank you, live. Who else? Nobody else. Rekomoditswe, thank you. The others haven't been using these. No? Okay. Okay, Benedicta, you're saying you're not sure about Euclidean. It's quite difficult. Yeah, I think Euclidean or Zayo. I don't like this section. Coco and I were just discussing this section before we had started. And yeah, we do understand, as teachers as well, a lot of students don't like this section. But yeah, it comes with practice. The more you practice these questions, the easier it becomes. I would suggest to you that the main thing that you need to know is your theorems and your proofs. If you know what rules you're going to be using, you will be able to answer the question, right? So I think what you should do is, which I've found that a lot of students find beneficial, when you get your exam paper, you've got all your theorems, you just quickly write down the shorthand versions of them. Like you see, this is shorthand, line from center perpendicular to chord. So on the screen here, you can see this is shorthand. These are the shorthands, right? So you can just write down all your shorthands very quickly. And then when you get your question, you can just see which of those theorems do you want to use. And you just by process of elimination sometimes find the right theorems to use, right? Because sometimes students get very stuck where they look at a question and they don't know where to start. But if you have your theorems next to you, you can then use those theorems to find the steps that you need to do in order to get the answers, right? Okay, so let's quickly run through the theorems. And maybe if you can write them down quickly, that would be really great, right? But I'm not going to give you too much time to write it down because we want to look at questions. But if you can write them very quickly, theorem 1, line from center perpendicular to chord. That's theorem 1, right? Okay, line from center perpendicular to chord. So we've got a line at the center and it's perpendicular to chord. So that means the chord is cut in half like that, right? Okay, so that's the first one. Okay, we've got the second theorem. Angle at center is 2 times angle at circumference. Very popular. This one here, angle at the center equals 2 times angle at circumference. So the angle at the center, if this is 2x, then the angle at circumference would be x, right? So if that's 2x, the angle at circumference would be x. Angle at the center is double that of the angle on the circumference, right? Okay, and then theorem 3, angle in semicircle. So we know if we've got a line that goes through the center, the diameter, the angle in the semicircle will be 90. So that's theorem 2 and theorem 3. I hope you've written those down. So we've got 3 theorems so far. Then we've got theorem number 4, which is angle in same segments are equal. So we've got your angle in same segments are equal. So it looks like this here. Okay, angle in same segments are equal. Okay, so that's theorem 4. And then we get theorem 5. Opposite angles of a cyclic quadrilateral are supplementary. So the opposite angles of cyclic quad, they equal to 180 degrees. So this and this is 180. And we have this and this equals 180. Opposite angles of cyclic quadrilateral are supplementary or equal to 180. And then we have theorem 6, which is the exterior angle of a cyclic quad equals to the opposite interior angle. So we've got this one here. If this is x, then that will be x, right? Okay. So that is theorem 6, exterior angle cyclic quad. Then we have theorem 7, which is tangent is perpendicular to radius. If you got a tangent, it is perpendicular to radius. Oopsie. Tangent perpendicular to radius. So here's the tangent TAN, and it's perpendicular to the radius PA. So this is 90 degrees. Okay, that's theorem 7. And then we have theorem 8. Tangent from the same point are equal. If you've got two tangents and they're from the same point, the two tangents will be equal, right? So we've got this tangent and this tangent will be equal, right? Okay. And then lastly, we've got the very popular 10-chord theorem, right? So 10-chord theorem. So we've got an angle here. It will equal to the opposite interior one, which is there. So TA1 equals C2. Okay, so the angle between a tangent to a circle and the chord drawn from the point of contact is equal to an angle in the alternate segment. And we call that the 10-chord theorem. Okay. Did you write down all your theorems? Please show me a thumbs up if you have your theorems written down, all 9 of them that we're going to be looking at. Do you have them all down? Okay, great. Thank you. That's really great. Okay. Thank you. Okay, great. We're going to go back to the other share now. I hope I do this right. Okay. Can you all see now the screen that's saying grade 12 paper 2 revision? Hey, Coco, is this fine? Coco still there? Okay.
Yes, that's good. Sorry, there's just quite a lot of noise where I'm at.
No problem. Thank you for that. Okay, so we're going to go straight to the question. How are you all feeling about Euclidean? Please message me with one word so that I know how you're feeling about Euclidean geometry. Okay. Okay, I can see from a lot of the comments that the section isn't one that you really enjoy, and it is quite a difficult section. Yeah, I'm getting answers like, I don't like it, it's really not nice. Some people are saying it's okay, and they're finding it fine. It's okay-ish. For some of you, it's confusing. But yeah, let's hope with a lot of practice that this will come right. It is a section that you do learn a lot by doing it very often because it is very visual and it is something that you need to practice very often, right? Okay, let's have a look at this question. These questions are from the 2017 November paper, and I'd like you to read the question first, and then we're going to look read the statement first, then we're going to look at the questions, right? Excuse me. So we can just read it and look at the diagram. Okay, so it says here in the diagram, points A, B, D, and C lie on a circle. CE is parallel to AB. You can see they've provided us with parallel lines. And with E and AD produced. So E and AD produced, okay, so it extends beyond the circle. Chords CB and AD intersect at F here. D2 equals 50 and C1 equals 15. Yes, okay. Okay. Great. Okay. Let's look at the questions. Calculate the size of A1 of A and C2. So let's look at that. First A, then C2. Okay, so first find A and then C2, right? Who wants to give it a go? Let's find A and then C2, right? You can just type in the chat with reasons what your answers are, right? A and C2, if I mark the angles, A will be here. Hey? So A and C2. Okay. A you say is 50 degrees, angles in same segment. Yes, there is angles in same segment here. However, I don't think it's 50. We must just check there. Yeah. Anybody wants to give me an answer? Nope. Let's start by doing this, right? We've got the parallel lines. What is the value of B? Let's start with finding B. What is B? What can we use to find B? What is B here? What is the value of B? 50. Thank you, Jaden. Jaden, if you want to unmute, why is it 50?
Because it's angles in the same circle segment.
Angles in the same segment, right? So question, so I'm going to write here 8.1.1. So we're saying B equals 50 degrees because it's angles in same segment, right? And here's the same segment. It's the same segment as this one. They're both 50, right? Okay, so if B is 50, then this whole thing here will also be 50 because it's alternate. Can you see the Z? Can you see the Z there? So B and C1 plus 2 will also be 50, right? Okay, so we're going to say here, angle B equals angle C1 plus angle C2. Okay. Yeah. Angle B equals angle C1 plus angle C2. Is that correct? Does everybody agree with that? You can just show me. Let me see what you're writing in the chat. Okay, yes, that's fine. Okay. Yes, thank you, live. Yes. So we've got here B then equals to 50. Right? Equals to C1, we have 15 degrees plus C2. So C2 equals to 35 degrees. Therefore, A also equals to 35 degrees because of angles in same segment. See here, the same segment here. This is A and this is 35. The angles in same segment, right? So we've got A equals 35 degrees, angles in same segment, right? Okay, so that is A, and we've actually also answered 8.1.2, which is C2, and that we're going to also say 8.1.2, we're going to say C2 equals 35 degrees, and it's also angles in same segment. Okay. Yeah. So A is 35, and then we've got C2 equals to 35 as well, angles in same segment. Does everybody get that? You can just unmute or say thumbs up or type in the chat. Okay, you get it. Thank you, Live. Thank you, Karabo. Thank you to the rest of you as well. Are there any questions regarding this? Asipe, Benedicta, Dineo, Mpo, Ozayo, are there any questions, Rehmoditswe? Ntando? Okay. Benedicta, do you get this question? Is it making sense? Benedicta? Okay, it is. Thank you. Okay, thanks, Rehmoditsu as well. So far, so good. Okay, great. Now we can move to the next one. It says, prove with a reason that CF is a tangent to the circle passing through the point CDE. So here we can draw a circle. I'm going to clear this diagram. But I'll put the angles in again. So we've got that proof that CF is a tangent to the circle passing through CD, C and D, okay, and then CF. Here's CF, right? Circle passing CD and here's CF. So it's a tangent passing through a circle, right? CDE. Here's CDE. Okay. So CF is a tangent to the circle passing through C, D, and E, right? So when we have anything with tangent, maybe if you can type in the chat, what sort of theorems do we use? What theorem do you think we'll use here, even before looking at anything? What theorem do you think we'll use? Yes, Benedicta 10 chord, right? So for 10 chord theorem, what we need to prove, we need to prove that C2 equals to which one in the circle? Which one in this triangle must it equal? So we've got a triangle here, right? So C2 must equal to which angle in that triangle in order for this to work? You can just type and let me know, unmute. C2 must equal to which angle in the triangle? Yes, thank you. Thank you for that. So it must equal E, right? So how can we find E? There's quite an easy way to find E. Look, we can find D1 because we've got angles on the adjacent line there, see? So what will D1 be? So we're going to say here, we're going to say D1 equals to, and we had C2 was 35, and then we've got D1, and we want the circle here, right? So what will D1 equal to? Yes, 130. So we're going to say a D1 equals 130 degrees. And this is adjacent angles on a straight line. And then we're going to say E equals to 180 minus 130 minus 15. And what's the reasons for this? Angles of triangle CDE. So E equals to 35 degrees. Therefore, C2 equals to E equals to 35 degrees. Therefore, it's a tangent because of 10 chord theorem, right? Right. Therefore, CF is a tangent to circle passing through CDE. Okay. I'm just going to write here, I'm just going to say is a tangent. Okay. And the reason for that is going to be converse 10 chord theorem. So it's the reverse of the 10 chord theorem, right? Converse. Okay, so we proved it using the converse of the 10 chord theorem. Is that okay, everybody? Who's got this answer? You can just show me a thumbs up or type in the chat. Is this okay? Asipe, live, thank you. Mpo, Ntando, Swelihle, thank you. What about you, Sia? Silindile? Okay, so Benedicta, just again, we've got D1 is 130 because it's on a straight line. And because we've got a triangle here, CDE, we can find E using angles of a triangle. So this will be 35 degrees. Therefore, C2 equals E, and it's a tangent because it's the converse of the tan-chord theorem. Okay, converse tan-chord theorem, right? Okay, great. Okay. Right, this is actually the end of this question. Any questions so far? You're welcome to unmute, or you can also type in the chat. Okay, let's move on to the next one. This question is quite a long question. I am going to try and do as much as possible. However, if not, I'm going to assign you for homework. So it says in the diagram, BC is the diameter of the circle. The tangent at a point D on the circle meets CB produced at A, and CD is produced to E such that EA is perpendicular to AC. BD is drawn. Let C equals X. Okay, right. We've got 3 1-mark questions there, which is the first one. Give a reason why D3 equals 90 degrees. And you're going to tell me, what do you think? Why is D3 equals to 90 degrees? What is the reason? Who wants to try? D3. Why is D3 equal to 90 degrees? Yes, great. Thank you. So this is because of angle in semicircle. Why is ABDE a cyclic quad? What can you tell me there? Why is ABDE a cyclic quad? Yes, why is it a cyclic quad? What is the reason?
Opposite angles are supplementary.
Yeah, opposite angle supplementary, we can use that. That's if this is equal to that, right? Or we can also say exterior angle equals opposite interior angle, because if this is 90, then that's 90, right? Is that fine? So exterior angle, right, of the cyclic quad equals to your opposite interior angles. Okay. And then the last one, why is D2 equal to X? Why is D2 equal to X? Who wants to take a try? Why is D2 equal to X? Here's D2. Why is D2 X? And they did tell us in the question, they said that AD, yeah, we've got to the tangent at point D. So it's a tangent, right? Circle meets CB. So it is, yes, anybody? We've got a tangent there, AD. So if it's a tangent, yeah.
Isn't it angle between the tangent and the chord is equal to the opposite angle?
Yes, so it's called the tan-chord theorem, right?
Yes.
Tan-chord theorem. Okay, great. So we've got the rules there. Thank you for all sharing. The next one says prove that AD equals AE. So prove that AD equals AE. AD equals AE. So where's AD and where's AE? There, AD and AE, right? So we've got here AD and AE. So AD equals AE. How can we prove that? So we've got D2 was X, right? Remember we had D2 is X. And A1 and A2 is 90. They want us to prove that AE equals AD.
I think we will prove that D1 is equals to angle E.
Yes, we need to prove that D1 is equal to angle E, right? Okay, just stay on the line there. So I want to know from you, what is D1 plus D2 equal to? These two, D1 plus D2 equals to 90, hey? Is that right? Here. D1 plus D2 equals 90. Does everybody agree with that? You can just shout out yes. Yeah?
Yes.
Okay.
Yeah,
And why
yeah.
is it? Because D3 is 90. So D1 plus D2 is obviously going to be 90 as well. Hey? Okay. Yes, thank you, Ntando, angle on straight line. So what does that make D1? So we know that D1 plus D2 equals 90, right? But D2 equals to X, right? D2 equals to X. So D1 equals 90 minus X. So D1 equals 90 degrees minus X. Okay, so D1 equals to 90 minus X. Are you all following with that? D1 is 90 minus X, right? Okay, any questions so far? We've just got D1, right? We need to find E. Any questions so far? No questions, okay. Now I want us to focus on this big triangle here. We've got 90 degrees in that triangle and we've got C2 is X and then we've got E on the top, right? So if we've got here, if I reproduce it here on the right-hand side here, maybe this will help. We've got 90 here at A, and then we've got E on the top, and at the bottom here at C, we've got X. So what does that make E? How are we going to find E? If we've got 90 and X and E, how do we find E? We say that E plus 90 plus X, what will it equal? Anybody? When we add them together, what will it equal?
180.
Because it is a
Triangle. Right angle triangle.
So E equals 180 minus 90 minus X. So angle E equals to 90 minus X. Okay. So we know that E equals D1, and we've proven it now that AD equals AE, right? So I'm going to write here, therefore, E equals D1, which equals 90 minus X. Therefore, AE equals to AD. Okay, because it is sides opposite equal angles. Sides opposite equal angles. How is that, everybody? So we find D1, we find E, and we show that they are equal to each other. Right? Okay, please type in the chat how you're feeling so far with this question. If you're understanding it, are you following it? Okay, thank you. What about the rest of you? How are you feeling so far? Remember, you're going to have this question. We do have it on the app, and you can look at it again. Okay, thank you, Jaden. Thank you, Benedicta. What about the rest of you? How are you feeling about this question? Okay, perfect. Thanks, Asipe. Thanks, Live. Thanks, Michelle. And we've got Karab. Okay, great. Then we need to prove that A, B, D, line, 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 A, C, D. What do those three lines represent in 11.2.2 B? What do those three lines represent? What is that? What do we need to prove?
Congruency.
Okay, ABD and ACD, congruency. Okay, I'm going to extend this in like that. ABD and ACD, right? I'm going to erase this here. ABD and ACD, right? Let's do this, but I'll have to erase here because I want to use this side to write down the congruent solution. Okay. So we've got ABD and ACD and ACD, right? You can erase this, this, probably this, this. Okay, let's do that, right? So ABD right, and ACD. So we've got two triangles there, ABD and ACD, right? What can we see? Remember, for congruency, you need to prove three things, right? So it's like side angle, side angle, angle, etc. What can we do here? What can we do to prove that they're congruent? How do we start? Anybody wants to help me start? What do we say in the start? We say in triangle ADB and triangle ACD. And we need to provide 3 reasons, right? Who can tell me what the first one is? What are we going to write for the first reason for congruency? Rosejo, Ozayo, Ntando? You've been quite quiet. Karen, you've been quiet. Swelile, anybody wants to help me? What do we say for the first reason? D2 equals C equals X. Thank you, Jaden. D2 equals C equals X. We're going to write there proven, right? Okay. Angle D2 equals angle C equals angle X equals X, proven. Who else? What else can we do? What else can we do? Anybody else? Look at the 2 triangles. What is common in both of them? Anybody else wants to help me share what is common?
There's a common side and a common angle.
Okay. So we've got common side and common angle. So what is the common side?
The common side is DE and DE, and common angle is A and A.
You mean DA, DA is the common side, hey? AD, yeah? Common side, is that right? Yeah?
Yes.
Yeah, okay. So, yeah, common side is going to be the DA and the DA. But I'm just noticing something here. We've got here the 3 lines going up like that, right? Some of you shouted out earlier that it was congruency. Is that right or is that wrong? I just realized something here. Is that right or is that wrong? The 3 lines, what is that? Yes, it's not congruency, it's similarity. It's similarity, right? Yeah, it is similarity, not congruency. Because the 3 lines there, it is similarity. Okay, so for similarity, we're not proving side angle side and side side and stuff. What do we prove for similarity? Anybody want to help with that? What do we prove for similarity? What do we prove for similarity? Anybody?
Angle.
Yes, so it must be angle, right? So it must be 3 angles. So we can't work with sides here, right? If it's similarity. So we've got a common angle. Somebody told me earlier it was A2, I believe. That was the common angle, right? So I'm going to say A2 equals A2 because that is common angle, right? Right? A2 equals A2, common angle. Okay. And then what's the last one that's left? So we've got D2, we've got A2, we've got B1, which is left. And then for the bigger triangle, what is left? We've got B2, sorry, B2. What's left in the bigger triangle?
D3.
D3 plus D2, hey? This one here. Okay, so we're going to say B2 from the smaller one equals to D2 plus D3. And we call this rule, we say sum angles of triangle, because it's just the remaining angles of the triangle, right? Okay, so D2 plus D3 equals to B2. Okay, and therefore, triangle ADB is similar to triangle ACD. And the reason, angle, or some people write it like this. Okay. So very important, the 3 lines going up is similarity. Okay, please let me know, how was this question for similarity? Is it okay? Is it challenging? Do you find it okay? Okay, it's good. Okay, thank you. Okay. Okay. So there is one part left to this question, but we are not going to look at it today. I'm going to assign you that as homework, and then we're going to see if you have any questions tomorrow. We'll have a look at that. Yeah, we will continue with a new section tomorrow. But yeah, just let me know so far with this question. These were just looking at the rules of your Euclidean geometry. How did you find the rules of your Euclidean geometry so far? You can just let me know. You're welcome to unmute or type in the chat, or send a thumbs up if you find. Let's look. Okay, thank you, Jaden. Okay, we've got live, thank you. Okay, thank you, Paul. Okay, so we've got this. This was from the 2017 paper. It was question 11. So you're going to look, just make a note of that as well, Coco, if you can, that, and all of you as well, but Coco will remind you, it's 11.2.3 that you're going to look at as extra homework as well from the 2017 paper, right? So it's November 2017. And that is paper 2. 11.2.3. That came out really weird. Let me just fix that. 11.2.3, A and B. Look at that and let me know if you have any questions tomorrow. But yeah, that is it from me for today. And I'm going to hand you over to Coco, and she's going to tell you where we're at and say goodbye. So thank you so much for contributing, everybody, and have a restful evening.
Thank you so much, Teacher Depesh. Guys, I feel your pain. This has also been like one of those topics for me as well. So I think we're in this together. It's quite a difficult section, but like Teacher Depesh said, we need to practice and make sure that, you know, we are kind of getting the visual clues, because you need to be able to read the picture in order to answer the question. So good luck, guys. Okay, I'm going to share my screen quickly. Okay. And this is what we are looking at now. We are on Wednesday, tomorrow, Teacher Depeche will be taking us through trigonometry, which is on Thursday. So we'll be looking at how to answer that section tomorrow. Today's homework, we're going to be looking at exam revision. And then we're going to be going to the 2018 paper, and we're going to be looking at questions 8 and 9. Those are the two that cover the circle geometry section. So if you guys can have a look at those. And do not forget the 2017, that last question there, question 11.2.3. Okay, that's all that we have from our side. Thank you so much, guys, for joining us today. Again, we will see you guys all tomorrow at 6 p.m. Bye, everyone.
Take care, everybody, and have a great evening. Study well.